Hello and welcome to our session about KEDA. My name is Jan. I'm a software engineer, also a recent addition to the KEDA maintainer squad. And I work for this guy, a man with unpronounceable name. So,
hello, guys. I'm glad to see so many faces here. My name is Zbynek, very hard to pronounce. Czech name, apologies for that. I'm also a KEDA maintainer. I'm with the project since the inception. And I'm also founder and CTO at Kedify. At Kedify, we provide enterprise version of KEDA. All right, let us start it. So actually, before we start, so we introduce ourselves. So maybe it would be nice to know a little bit more about you folks. So may I ask you who runs KEDA in production? Is there anyone? Nice, nice. Is there anyone who is considering running KEDA in production? OK, nice. And is there anyone who doesn't know what KEDA is, or maybe just heard about it and don't know the details? All right, I can see a bunch of folks. Great, so we have a great coverage. So I will try to do a very short introduction to KEDA, very short one for the people who don't know what it is. We'll briefly cover new features, and then we'll spend some time on best practices and some challenges that you can face when you are going to do autoscaling. So what is KEDA? With KEDA, we try to make Kubernetes Autoscaling as simple as possible. So we allow you to scale your workloads or schedule any Kubernetes jobs based on events, custom metrics, not just CPU or memory consumption and metrics like standard HPA on Kubernetes. We have, I believe, 65 plus, maybe almost close to 80 integrated event sources. So the event source is the source for the scaling decision, Prometheus, and Kafka.
And a fun fact, we usually like to pronounce it KEDA, not KEDA, because KEDA in our language, that actually means manure. So
yeah. Please do that or whatever you want. But please don't use KEDA. KEDA, no. KEDA is the best one. All right. We have an awesome community. We have a lot of contributors. If you are a KEDA user, we have also like this survey, which helps us understand what's missing in the project or what not. So please fill it if possible. If not, it's fine. So what is KEDA? I will try to do KEDA in maybe 2 minutes, so please, Jan, take it.
All right. Yeah, it never happened in 2 minutes, so
all right.
Let's see.
So KEDA is obviously built on top of Kubernetes. So from the beginning, we try to reuse as much concepts from Kubernetes as possible. We don't want to reinvent the wheels. So whatever works on Kubernetes, we try to augment it with KEDA. So this was the original idea behind actually creating KEDA. KEDA operates on a bunch of custom resources, and it manages the workloads, scale them, and also scale to zero. KEDA has few main components. The main one is a KEDA operator or a controller, which manages the custom resources. It opens the connections to the external services that we are using for the scaling decisions. And then it forwards metrics. And the metrics are being consumed by HPA controller in Kubernetes API. So the HPA, as it would like to scale, it asks KEDA metric server for an update on the metrics. So this is important to understand that for this reason, there could be only single KEDA installation in a cluster because it occupies a specific endpoint, and there is a Kubernetes limitation that allows us to only use single component for the external metrics consumption. So this is the architecture. I believe it's covered well, right?
Zbynek, that was fantastic. I think a record time. It's really, really great. Also, I have absolutely no idea what you just said. If you could please elaborate a little bit further.
OK, I can do that. So KEDA operates, let's say, there are two main use cases and concepts what you can do with KEDA. So the first one is horizontal scaling. So you are adding more replicas of your workloads, and this is managed by scaled object. So scaled object, you can imagine, if you are familiar with HPA, for example, so it is an object resource where you define what you would like to scale, how you would like to scale, and by what metrics. So in the scaled object, we define the target. So it could be deployment, stateful set, or any custom resource that implements scale sub-resource. So for example, Argo rollouts. We can target them with the scaled objects.
Can I also implement my own custom resource?
Definitely. Just don't forget to implement the scale sub-resource. It's easy. In the scaled object, so we define the target, and then we can define let's say the scaling configuration, how many replicas do we want to, if we want to scale to zero or not. And then the important part is a trigger section. There we define the scalers, and there could be multiple scalers targeting different applications, different services. Kafka, RabbitMQ, Prometheus, whatever. So you can combine all these signals into single scaling decision. So the rule is that for a single workload, you need to configure only single scaled objects. So there is like this one-to-one relation. And because we are using HPA under the hood, you can also specify HPA-related configuration to tweak the scaling behavior. We will cover this a little bit later on. The second, let's say, type of resources that we can do is we can schedule Kubernetes jobs. For that, we have another resource which is called scale job. And scale jobs, you can imagine it as a cron job on steroids. So instead of creating Kubernetes jobs based on some strict schedule, we can create those Kubernetes jobs on demand as there are some events or those custom metrics, the very same metrics that we use for scaling with scaled objects. So these are like these two main modes, and it's a really powerful combination because you can do really a lot of things. The general rule for me is that if you can expose any metric about something that's happening in the cluster, you can definitely target it with a scaled object or scale job and do some scaling magic in your Kubernetes setup. So this is like this is what KEDA is. What is the, let's say, overview? There are some new features in KEDA. I haven't done much recently, so apologies for that. So maybe Jan, you know what's there.
Yeah, as I mentioned, I'm a more recent addition to the maintainer squad, so I also have absolutely no idea what has happened in the last year. But luckily, there are more maintainers on our team, and they have done a great job at putting this slide together for us. We have a bunch of new scalers. Half of the technologies I heard for the first time in my life when I saw the slide, but they are very popular and great technologies. Also, there has been internal improvements on like a fallback strategies.
Okay, Jan, wait, what's fallback?
A fallback. Great that you ask. Thank you. I came prepared at least for that. So when you configure your metrics, the server that is supporting those metrics, that's providing them, can be down. Like, it's a real thing that happens. Recently, it even happened to AWS.
So this metric server is like a Kafka, or what is it?
Yeah, it can be anything. Kafka is a good example, but even it can be internal metrics of AWS. Now, what happens when it's down? You still probably want to maintain some sane level of replicas for your workloads. So that's a fallback behavior. Now, it's richer. In the past, you would configure just a static number, and whenever something was down, you would autoscale to that static number. Now, you can configure and fine-tune different strategies. I think that's pretty powerful. And also, we're now building on new architectures that we haven't in the past, and we are routinely testing.
Cool thing. Yeah. Thank you for the explanation. So now I know what KEDA is, how it works, what are the new stuff. So maybe we can talk a little bit more about the best practices, because I have the knowledge now. Yeah?
Yeah.
OK, thank you. So the first thing, this is very simple stuff, but very powerful. So please always specify the scaling behavior. Scaling behavior is a native configuration to HPA, and because we are using HPA under the hood, you can configure the same stuff through our scaled object resource. Why this is powerful? Because it tells you the profile of the scaling between 1 to n replicas, because scaling from 0 to 1 is been handled directly by KEDA operator, because HPA cannot scale to 0. But from scaling from 1 to n replicas, it's been managed by HPA. So in the scaling behavior, you can specify how fast you would like to scale, so how many replicas you would like to add at a single iteration. You can also specify stabilization windows. So if you have some let's say spiky metrics, so it goes up and down, up and down. So the stabilization window serves the purpose that it tries to smooth the curve a little bit, so you don't see like the fluctuation in the number of replicas. So it's very powerful. Please spend time properly configuring the scaling behavior. It's very, very powerful.
Now, there's the same default, but every workload is different. Every workload has different challenges, so it's good to learn about your workloads as well.
Yeah, exactly. Cool. The other thing, this is very, very common question from our users. So they are using cron scaler. It is one of the scalers that we support. And cron scaler allows you to scale some workloads based on a cron schedule. And they would like to scale some workloads to 0, for example, outside working hours. So imagine you have some dev environment, some staging environment that is being not used through the whole day or maybe a week. It's been used only for example, during working hours. So outside of working hours, you would like to scale it to 0. And the common mistake is that in the cron scaler, you specify the desired replicas to 0. So you would specify, during this cron schedules, please scale to 0. That's a bad idea, because the cron schedule actually works the other way around. So you cannot specify the 0 there, because the cron scaler under the hood, sends metrics to the HPA, and it doesn't work this way. So you need to specify the opposite. So you specify in the scaled object, you specify that you would like to specify zero number of minimum replicas. So if minimum replicas is specified to 0. And in the cron schedule, you just specify the window when you would like to have at least some amount of replicas instead of 0. So for example, you will specify minimum replicas to 0, and in the cron schedule, you will specify 5 for the working hours.
And Zbynek, will that be a static number, or can I combine it with other scalars?
So the default is static, but we have another powerful concept in the KEDA, which is called scaling modifiers, where you can a little bit play with the scaling metrics. I will cover this a little bit later on. The other thing is polling interval. This is a very common question from our users. So in a scaled object, we define a configuration which is called polling interval, and in practice, it means how often KEDA operator asks for new metrics. But again, because the scaling from 1 to n is being handled by HPA, it's the metrics Kubernetes API server that drives basically the polling. So the polling interval is only used for 0 to 1 scaling. For the 1 to n scaling, please use the HPA behavior configuration, which I covered just recently. And if you have a minimum replicas larger than 0, please don't specify the polling interval at all. It just adds unnecessary calls to your services. So if you specify the polling interval to a very low number, then you can overload your service, for example, the Prometheus server. Because every 15 seconds, which is the default on Kubernetes, HPA asks for the metric, and also the polling interval for KEDA could be like this low. So there's a lot of traffic happening there. So please specify the polling interval only if you have minimum replicas larger than 0, and if so, please be careful on the setting there. And yeah, scaling modifiers. So this is the feature that Jan hinted me on. So scaling modifiers are very powerful, actually. They allow you to specify the configuration if you have multiple scalars, for example. Because the default for HPA, KEDA, and Kubernetes is that if you specify multiple triggers, so you can target, for example, multiple Kafka topics, you can target Prometheus, CPU together in a single scaled object, then the default evaluation is that the largest value wins. So whenever a scaler tells us to scale, for example, to 5, and the others tell us to scale to 2, for example, the largest value is being selected. This is OK for some cases, but we were thinking about, OK, let's augment it a little bit. So with the scaling modifiers, you can actually, for example, say, let's use average, let's use minimum, or we can even write the mathematical formulas with some conditions, operations. So we can do really fancy stuff with the evaluation of between the different triggers there. There is one good example for scaling modifiers. Also, if you have just a single trigger specified there, there was a question from one of our users. They were like, we are scaling some service. I believe it was based on RabbitMQ. And we would like to be over-provisioned by 3 pods at all the time. Whenever the number of replicas is, we would like to have 3 pods extra, because we know that each pod can process 3 messages. So the easy stuff was with the scaling modifier. So in the scaling modifier, in the mathematical formula, we just said, use the value from the trigger plus 9, because 9 is 3 pods for 3 messages, and it was easy, and it worked flawlessly for him. So it was a great solution using the scaling modifiers. All right, so these are let's say, the easy topics, and this one is actually maybe quite controversial.
Yeah, it's an understatement. Like, when I think of metrics, Prometheus, to me, that's a synonym of metrics. And you're saying that I should use metrics to autoscale. So what does it mean that I shouldn't use Prometheus?
Yeah, because Prometheus is very simple, or the easiest way how to start with custom metric scaling is through Prometheus. Because usually you have Prometheus already in your cluster. And so it's very easy to just scrape the metrics from Prometheus and scale based on that. It's perfect. It works. So I'm not saying it's a bad idea, but only for certain use cases. So if you have a smaller, let's say, deployments, or let's say smaller fleet of resources that you are scaling out, it's perfect solution. But once you are starting to, let's say, scale out also the size of your environment, and you have a lot of services, all of them are being scaled by Prometheus metrics, KEDA, again, needs to ask for the metric every couple of seconds based on the polling interval. HPA asks for the metric every 15 seconds. So it's a very common question from our users that they are mentioning. We are using Prometheus, and now we are seeing all these context timeouts and all these evaluations, and scaling is broken. It's because Prometheus is not able to handle all the load that is coming there from KEDA, and you can easily override it. The same case, it could be with Datadog, for example. So if you are using Datadog for metrics, it's very easy to set up, use it. But once you are in a larger scale, you might be rate limited by Datadog because you are making too many requests for the metrics. So be careful when you are using Prometheus scaler. I know it works for a lot of cases, it's perfect, but once you start seeing some issues with the scaling, it's probably because of that. And the other reason is also, or maybe other thing that is related to that sometimes users try to make the scaling as fast as possible. So you would like to react as soon as possible there is a new metric. So they reduce the polling intervals even to, for example, 1 second or 2 seconds. So every second there is a lot of polling from KEDA to Prometheus or Datadog. So it hurts actually the overall performance. And the last aspect is actually, if you think about the whole idea, because when I was talking to some users, and they were like, oh yeah, we are using Prometheus, and we use the Prometheus just because of the scaling. So we deploy the Prometheus only for the scaling metrics. And if you think about it, so you have the metric which is already in cluster, then you send it out of the cluster to Prometheus instance, and then back to Kubernetes. So it makes a lot of, let's say, it could be cross-zone traffic. It could be a lot of ingress traffic on the overall cluster. So the suggestion is always, be careful when you are using scalers like Prometheus or Datadog, and if possible, try to minimize the footprint and try to get those metrics directly from the workload to KEDA.
So what are my options? If I have Prometheus, I have the metrics over there, but I get rate limited by the Prometheus API. What can I do?
Yeah, so we have a open telemetry scaler, which is done by Kedify, but it's open source, so you can use it. And it's an external scaler for KEDA, and it allows you to directly scrape the metrics that are in the cluster and send them to KEDA. You can use it; it's perfect. Or if there is let's say, for example, the Prometheus metrics are capturing, for example, Kafka metrics or metrics from the system. So please use the direct metrics, not through the Prometheus. All right, that's your turn, right?
Perfect. Yeah. Thank you so much. Now, I will run through a couple of examples. Now, I have been around for some time, as you may have guessed by the color of my beard. And I have also seen some things, as you may have guessed by the lack of hair on my head. And recently, one discussion caught my attention. And it happened as a discussion on SIG autoscaling mailing group. And there was a proposal. And it was a totally legit proposal. In a situation where you have a bunch of related workloads, you want to autoscale them in a synchronized fashion. You don't want to wait for a lag of the HPA to start autoscaling, but you know in advance that a certain service is going to be hammered by requests once you autoscale another part of your infrastructure. So this coordinated way of scaling, now, how you can imagine it, this is a situation. So there is some traffic going to your front end, and the front end needs to pass the request to backend A, which passes it to backend B, so in a chain fashion. And finally, when backend C responds, it goes back, traverses back all the way to the front end. What happens if there's more traffic? Now, your front end is having a bad time. That's the first thing that's going to happen. But luckily, you have HPA. So HPA, what it's going to do is going to start autoscaling. But there's this HPA lag. It takes some time before it reacts because there's a polling intervals. Your application has to get super busy to cross the certain threshold, and then it's only autoscaling. Now your front end is in a good shape, but the traffic and the problems, they propagate down your stack, and now your A backend has a problem. It's not scaled sufficiently. So you have another HPA lag, and then it starts autoscaling.
It's breaking already. Yep.
Then that propagates to backend B, which propagates to backend C. And only now, when all of your backend services are scaled up to a sufficient level, only now your front end is starting to actually be happy about the whole situation, and your users are starting to improve their user experience. There were two ways out of this problem proposed in that proposal. One was in-tree modification, so changing the HPA API. And I don't know if you have a lot of experience with like sending patches to Kubernetes, to the open source part.
I do.
How was it?
It was a great experience, but it took some time, yeah.
Yeah, it's a good learning experience, but you're looking at a timeline of north of 6 months, maybe 2 years. In this particular case, it would be a change of a HPA, which is a stable V1 core API. So you're very likely not going to be met with a lot of enthusiasm from the maintainers, because it would mean a lot of backwards compatibility nightmares. Now, a second proposal was a custom resource, and that got me thinking. Now, I think I know of such custom resource. So back to this scenario, you have HPA, you have your deployment, you have traffic. Now, this is how easy it is to move from HPA to scaled objects and KEDA. It's a one Helm chart installation, and then whatever HPA supports is natively supported also by a scaled object. So the first one, for the front end, you can use the same triggers. You'll still measure CPU and memory. You'll also still have that HPA lag, but for the backend A, B, and C, you'll have a slightly modified scaled object. And how much modified is something I'm going to describe right now. So this is a minimal version of a scaled object. It's a lot of letters, so let's dissect it by sections. This is like a minimal HPA configuration. Like this is pretty much matching one-to-one a scaled object to an HPA using CPU.
So this is the original config that was with the previous example, right?
That was the original. So you don't have a lot of work to do if you want to migrate. And now this, if there was a competition for like the worst aligned slide in the world or in the history of slides and presentations, this would be very, very high up in that ranking, but it amplifies the point so well. So it's a minimal change. Here, there is a trigger. There is a scaler called Kubernetes workload. And what it does is, through a pod selector, it measures how many pods of that other deployment are running, and it will insert that as a metric for your scaling. So here, this is the backend A. You're scaling a backend A by the number of replicas of frontend. So whenever your front end is scaling up, you're chaining that reaction and you're scaling away sooner than the HPA lag hits your services.
Yeah, this is a very good example. Maybe one of the issues that is in general with the CPU or memory, let's say, metrics done by HPA, because it's reactive. So the CPU or memory metrics are good for certain workloads, some stable workloads, etc. But they are reactive, so they react to the state that's happened. But you would like to prevent the state. You would like to prevent the, let's say, overloading of your application. So that's why like those custom metrics or like those more proactive metrics are much better suited for this kind of workloads.
And in our, again, virtual scenario, you still have that front end. It has a scaled object, but that's one-to-one maps to HPA. So you're still hit by the HPA lag. But as soon as your front end starts scaling up, that's when your backends, all of them, will start scaling up. So there might be a little bit of a lag between the traffic hitting your first backend, but that's definitely going to be a way faster way to recover and stabilize your infrastructure.
I would like to have a proof of this statement.
You'd like to have a proof?
Yes.
I was waiting for that. I was ready. So we have a live demo, and I don't know if you've noticed, but the Wi-Fi here is not the best. So when we learned about it yesterday, we decided that we were going to do the one thing that any coward would do and record our live demo. So it's a recorded live demo.
So it's like a half proof, right? So it's not like a real proof. It's my computer, so I can help you with that.
Yes, I'm a dinosaur. I don't know how to use computers.
Yeah.
All right. So this is the scenario where you have that standard situation where everything is scaled by the metric. Now, this is a special case of the previous scaling. This is a scale to 0. It's using KEDA HTTP add-on, which enables you to scale to 0, not lose any traffic, and be able to kind of work in a similar fashion that AWS Lambdas, for example, do. Just build it yourself on Kubernetes. So you have front-end deployment, back-end A, B, and C. They're all at 0 replicas. I'm going to hit a spacebar and send a request to the front end, which is going to proxy it back to back-end A, B, and C. Now, first thing that's going to happen is the metric hits KEDA, KEDA will start scaling. There is a little bit of period before the pod gets ready. And as soon as it gets ready, it will send the request to backend A. So now it's ready. The traffic is moving, propagating down the stack. And it will scale A, B, and C in this order.
And here, maybe like one mention, it's like also with autoscaling. It's in general like cloud native space. If you would like to scale out your applications, please make sure that they could start as soon as possible. So because the stuff that you can see here at the moment is like the cold start, that's been handled or caused by the application itself, because the application needs to be started, container, etc. So please make sure that the applications are ready for the cloud natives, let's say, approach.
Yeah, and sometimes that's not really possible. I'm talking to you, Java.
Yeah, Python.
And here you can see all the backends are ready, and it took 59 seconds for the traffic to propagate down the stack. Now, for a comparison, this is exactly the same command, exactly the same thing. The only difference is the backend A, B, and C have now that Kubernetes workload trigger on top of everything else. So I'm going to hit the traffic, and you can see instantly that as soon as the front end is starting to scale up, all the backends are also starting to scale up. So they're not waiting for the traffic. They're not waiting for their internal metric. They're chained. And as a result, the overall experience is a lot better.
Yeah, much faster.
It took 19 seconds.
Cool. Nice. Thank you.
All right. How are we on time?
We are almost on the top of the hour. So.
All right. So I'm just quickly going to cover another topic that we wanted to chat about. That's scaling groups. That's a little bit different than the chain scaling. Now, in this situation, you have a bunch of services, and they are not related. They don't talk to each other. They scale independently, but all of them reach to a common database, for example. And your database usually has some capacity, some amount of traffic it can serve. And for this theoretical scenario, let's imagine that it can handle 10 connections. Now, you can scale each scaled object independently, but then you're risking a couple of different scenarios. Like one thing that can happen is you split the cap. So you take 10, you divide it by 3, you assign a maximum of 3 to each scaled object, and when you assign a 3, you're still left with 1. And there's also going to be a lot of other unused capacity because, again, they scale independently. So one of them can be super busy. The other two, they receive no traffic at all. So you're leaving like 7 potential replicas on the table and not scaling at all. But a benefit is that you don't risk any starvation. If everybody's busy, everybody's going to get a fair share.
Yeah, Jan, we need to scale out. We have almost at the top of the hour, so speed up, please.
So the max, that means you risk autoscaling. You assign everybody 10, and you can overcommit. That's a bad situation because everyone then your application will be starved. And we touched topic about the scaling modifiers. And the scaling modifiers in this particular situation can help tremendously. Please talk to us if you see us on the, around. This is a scaling modifier. Yeah. This is the one.
Yeah, sorry for that. I was too quick. So this is the session feedback. So please, if you like the session, send us feedback. If you would like to talk about autoscaling, about KEDA, you will find us at Kedify booth. So we have also some cool swag there. So please stop by and play with us. Thank you. Are there any questions? Yeah, could you please use the microphone?
For now, KEDA is using the HPA, and I think we should benefit a bit more if we could also use VPA on KEDA. Is it in any site or something?
Yeah, it is like a common question. So VPA, like the main benefit of VPA usually is like by monitoring the CPU memory metrics, right? So we are thinking about extending VPA with custom metrics, the similar way it is done for HPA. But it kind of doesn't make much sense because it's like a very edge use case. Usually you would like to extend the resources by the actual consumption. But there's a problem, because you shouldn't combine HPA and VPA together if both of them are using, let's say, the CPU or memory resources. So you can use the combination, but only if the HPA or use scaled objects, and they are using different metric than the CPU memory. But we are still trying to figure out how to let's say combine both approaches here.
Hello, guys. If I want to use KEDA to scale a custom resource definition that doesn't have a slash scale, and maybe KEDA can use a simple Kubernetes patch to the custom resource definition and don't use the API, the normal API way to scale, if you think about it.
I probably don't understand the question.
So yeah, the KEDA in its code base.
I want to use KEDA with a custom resource definition, for example, model serving inference service. And inference service doesn't have a slash scale in the subsys.
Yeah, scale sub-resource,
Yeah. So KEDA can use a simple Kubernetes patch to patch the resource, and then the controller of
and this is actually what the scale sub-resource actually does. So it's like a unified interface how to patch the replicas on the workload. So if we would like to support all different resources, you would need to have the RBAC for all of them in KEDA, and KEDA would need to, like the implementation, would need to know the object before it's actually, you need to know the API. And if you are using the scale sub-resource, it's like a simple API in Kubernetes, and you can target any workload, So it's much easier for us to, it's probably easier to patch the CRD, because the scale sub-resource is really like a mapping between the labels on the resource, on the CRD, with the replicas field. So it's very simple. It's very simple.
Okay, I will take it with you.
Yeah, we can talk later,
Hey, hello.
Hey.
So back to the earlier example of the front end and the back end scaling off the front end. Is it possible or just not practicable to have the back ends, instead of actually scaling off of the front end's action, just simply monitoring the CPU usage of the front end, the same thing that the front end would be watching?
So technically, you could inject the labels of a metric from the front end into the HPA, but then you're losing the benefit of also scaling independently. Like there might be multiple different paths to your backend services, and not all of them will go through the front end. And you will only scale if the requests go to front end, if your front end is busy. And also in this particular scenario, what you get as a benefit is the Kubernetes workload allows you to configure ratios. You don't have to scale one-to-one. You can scale faster or slower. And with the scaling modifiers, any arbitrary mathematical expression that you can evaluate can be a modifier of the metric. So, and an additional benefit, if you have multiple front ends, you can put them there directly. Like if you use a label in HPA that targets a different metric, then you're fixed to there.
Understood. Yeah, I was just thinking the benefit of actually having them both the front end and the back ends, at least the back end's having a one of the metrics, I can't remember what the term is.
But like I understand what you mean.
Scale at the same time instead of actually one feeding the other.
Like this was like a, let's say, arbitrary example, but for some cases this makes sense, to target, let's say metrics that are not related to the actual workload. It's a good practice. So feel free to do it. It's always about the specific case, specific use case. So that's definitely doable and something you can do. Yeah.
Thank you.
Fantastic project. Thank you guys so much. Thank you.
Hey, one question on especially the Java workload. I have seen the challenges, when you scale up, going back if based on memory, because JVM is not going to release the memory. So what you can recommend on that one,
So my suggestion would be to expose as much as possible from the JVM metrics, actually, and use them for the scaling. So instead of waiting for the memory, I don't know, there might be some, for example, size of the thread pool or something like that. Would it help?
Okay. Now, right now, we are trying to use that request count or something like that one to see that one, if more requests is coming or not, to scale down, Yeah.
Okay, maybe we can.
That was a challenging one. I know that one,
Yeah, talk to us after the call. Yeah, after this. Yeah, happy to chat about it.
And we forgot to mention the 3:30 challenge.
Yeah.
A lot of people left, but yeah, if you find our booth at 3:30, there's going to be a puzzle, And in that puzzle, who assembles it first can win some prizes. So yeah, stop by 3:30 today.
Yeah. So thank you.